Thank you, Jordan. So today I'm going to talk how the Apache Lucene more like this works. It's going to be a talk a little bit more into the internals of Apache Lucene and Solr. So we've seen so far how you can use Solr, how you can scale it up, use it in the cluster. Now let's take a look how it works internally. The talk will mention a lot of time Apache Lucene. Apache Lucene, for the people that don't know, is the library, the Java library, which is used internally in Solr to provide information retrieval functionalities. It's part of the same Apache project. So effectively, if you go to the Apache Solr, Apache Software Foundation project, you'll find both of them as separate modules. So some of you know me because I used to work in Laboratories. And for the people that don't, my name is Alessandro Benedetti. I am a search consultant and a research and development software engineer. I have a master in computer science from the Roma Tre University in Italy. I'm from Italy. And I love Apache Lucene and Solr. So I've been working with Apache Lucene and Solr since 2010, and active part of the community, been supporting a lot the community through the mailing list, and contributing back as much as I could. I have been working around Solr on a lot of different topics. My favorite, natural language processing, semantic search, so enriching Solr capabilities with semantic search, machine learning, so integrating search with machine learning technologies. And then we will see later on some of the topics we cover with my company. Not related to Solr, but I play beach volleyball, not in London, when I go back to Italy, and I go snowboarding quite often, not in London, when I go back to Italy. So, a little bit about my company. So I founded CISE 2 years and a half ago, November 2016, effectively just after leaving the holidays. And we are 3 people now. We are open source enthusiasts. We work on Apache Lucene and Solr mostly, a little bit of Elasticsearch when it happens. They are pretty similar technologies. We are actively contributing back to the community. As Charlie mentioned, we contributed last summer a search quality evaluation tool to the community to be used with Apache Solr and Elasticsearch search engines. And we are also active researchers, so we work on a lot of topics that are like, of course, quite established in the academic world, but are still new in the open source community. And effectively, the mission is to build a bridge from academia to industry through open source software, which we believe in too. I mean, we strongly believe open source is the way to aggregate communities, to actually, it sounds a cliche, but building a better world, to give it back a little bit of what we actually use. So what we mostly work on, learning to rank, document similarity, which we will talk today, search quality evaluation, and relevancy tuning. And this is a list of our customers. So today we're going to talk about the Apache Lucene more like this. It's a very well-known feature from a user perspective, not very well known from the internals. It's implemented in Lucene, but it is exposed through Solr. So it's very likely that you may have used it in your company through Solr, but effectively the implementation is in Lucene. We're going to talk about the Apache modalities, the way you use core terms, the kind of different algorithms you can use to assign a score to different terms, extracting interesting terms from documents, and then building the query. If you're going to have time, a little bit of demo to see how it works in Solr and how the queries are built. Problem. You have a document and you want to find similar documents in your corpus of information. There are different solutions and different concepts of similarities. The collaborative approach is based on user interaction. So something is considered similar if you interact with it in a similar way. So similar users interact with similar documents in similar ways. Content-based, the Apache Lucene more like this is content-based. So two documents are considered similar if they share similar terms distributions. And then you may have like hybrid approaches which combine the two of them, but it's not what the Apache Lucene more like this is about. Real world use cases, even if you didn't have the chance to work with the more like this in your company, there are like a lot of services that offer this to you. This is a screenshot from a very popular streaming service that allows you to select a show, or maybe you already watched a show, and propose you like similar shows to that one, with like a percentage of the match. Or low holidays. Low holidays offer you this, the more like this functionality. So when you explore an hotel, you may be able to see similar hotel to that one. And the similarity in this case was based on different factors. So not just term distribution, but also the distance to the star rating and geographical distance of the hotels at the time. Maybe it has been implemented differently now. Apache Lucene. So, how many of you knows what Apache Lucene is? Oh, okay. It's the Java library behind Solr. So if you use Solr, you may not know effectively what Lucene is until you go into the deep inside of Solr. But effectively, all the information retrieval functionalities, so the effective way to match documents, score documents, find similar documents to the query, to other documents, this is implemented in Lucene. And Lucene is written in Java. It's based on the concept of structured documents. So the unit of information in Lucene are documents. Documents that are structured in a sort of map-like approach. So you have the key, which is the field name, and values, which are the contents of the field. How it provides search through an inverted index, pretty much similar to what you find at the end of a book. So terms associated to documents that contain the terms. And specifically, this is per field. So it's not just one big inverted index, but it's divided into different fields. Out of the inverted index, there is an implementation of various similarity metrics based on term distribution that allow you to score documents after you retrieve them. It's very fast. It's, from an open source perspective, a very valid solution to approach information retrieval. And being open source is easily customizable. You can implement your own plugins, and it's fairly readable for quite a complex project. Let's take a look a little bit to an inverted index, just to have an idea of how documents are effectively searched. So normally, at this time of our history, you proceed with a query that effectively describes your information needs. The query is moving to a lot of more like a natural language approach, but still is composed by terms that are then present in the document. So the idea was like, okay, so let's build a data structure that associates terms to documents, because this is what people are going to ask to the search engine. And you don't store only the document list, you actually store also the position of the term, how many times the term appears in the document field, potentially the offset in characters that basically give you the ability to highlight these terms in the results, for example. And this is just an example given like 3 sample documents, their related inverted index. The more like this. So the more like this solves the problem of retrieving similar documents to an input document. So you provide a document, and you're looking for documents in the corpus, so in your index, that look similar. Similar, of course, from which kind of perspective that we said at the moment, term distribution in specific fields that you pass as parameters. So the more like this takes in input a set of parameters. Most of them are defaulted to some values, so to use it you don't need to know all the parameters of the more like this, which are quite a lot effectively. You can specify the minimum term frequency of terms to be valid to build the more like this query, the document frequency in the corpus, the length of the terms we want to use, how many terms to use from the input document. There's a lot in there for customization. Once you pass the parameter, and that is configurable, again, a lot of defaults, so you don't want to touch them, you could potentially don't do that. And the rest can be done, for example, if you use Solr to access the more like this through Solr configuration. Then, how the more like this works? It takes in input the document, it takes in input as a basic parameter the list of fields you want to use for similarity. So potentially you have a document, you want to find similar documents based on the title, the abstract, and the authors of that paper. Out of these fields, the monoliths extract interesting terms. So terms that represent the document. How is possible to assign a relevancy score to a term effectively is kind of similar problem to a way you assign scores to documents in the result set. So you may apply the same logic, and effectively the monolith at the moment uses TF-IDF to score documents. We will see later how BM25 works, which is like an improvement on top of TF-IDF. Anyway, it's based on terms distribution. After you retrieve the top K terms from the document. At this point, you can build a query and run the query against the Lucene index. So effectively, you don't do any kind of comparison one versus one document. You don't do like vectorization. You just build a query, and then you run a Lucene query to find the Lucene documents. So as we mentioned, the parameters are like a vast array of different ways you can configure them like this, and effectively, most of them are defaulted. So it's not mandatory for you to explore them if you don't want. Now let's spend a little bit of time about the term score. So how you can assign a score to a term within a document context. So the term frequency inverted document frequencies approach is based on a couple of basic concepts, which are a term is more important as rare it is in the corpus. So if something is very rare, it's very likely to be important if it's present in a document. This is the first concept. So it is an approximation. It's not really true in some of the cases, but how Lucene estimates the importance of a term is through the appearance of the terms in the corpus. And then how many times that term appears in the document. So another approximation is locally the term is going to be important if it is appearing a lot of times in the document. Again, it's not true in all the domains, but it is a good approximation. BM25 has been effectively developed in the 80s, but has been introduced around 2016 in Lucene. Yeah, that's the way. That's the reason we say, okay, let's build a bridge from academia to industry, because there's a huge gap, at least in the open source community. I mean, probably the BM25 was used in a lot of other contexts much before Solr. It's called BM25 because it has been like the 25th iteration in improving TF-IDF. It's based on the same concepts. So time frequency, inverse document frequency in the corpus, and the document length, but in a slightly different way. So the inverse document frequency component of the term scoring is pretty much the same, so we can ignore it. The two more important pieces of the BM25 approach is we don't want to increase relevancy, so we don't want to increase the score of a document for a term, just asymptotically increasing the term frequency locally in the document. So if we continue to increase the terms occurrences in the document, this doesn't mean it's actually more relevant. We reach a point that we actually could provide a saturation. And this is what BM25 does. So you can specify a parameter that, again, is defaulted, so you don't need to necessarily to touch it. That will reach a point that say, after n occurrences of a term, you're not going to get a better score if you continue increasing the terms in the document. And when we take in consideration the document length, so a lot of occurrences of a term in a very short field means that it's more relevant than the same number of occurrences in a very big document. Like in the title, if you find a term twice in the title, it's much different than twice in a book of 100 pages. But BM20, and this was absolute in TF-IDF. BM25 does an improvement. It says like, okay, yeah, let's consider the document length, but in comparison, so in relation to the average document length. So if all the fields are very long, and you have like a long field, it's not that bad. On the other hand, if all the fields are very long and you have a very short field, this means something different. So let's see how the more like this extract the interesting terms. So as we've seen before, you need to extract terms from the original document and build a query. So and we know now how you can score a single term, but how we can produce the terms. So in here, the more like this will do, you have two different paths. So if you store as an additional data structure in the index term vectors, which is basically a per document inverted index, to make it simple, which of course costs a lot more space. But some functionalities in Solr and Lucene use this additional data structure. So if you want to use it, more like this will be able to immediately fetch all the terms and then calculate the score of each term. If you don't have term vectors, at runtime, the more like this will analyze again the context. So we'll apply the analysis chain you configure potentially as an additional parameter, split up the text in different terms, and then score each term with the algorithm we've seen before. A lot of parameters affect the interesting terms retrieval, because you can say like, okay, I don't want to extract all the terms, I want only the one that appears a certain amount of time in the document input, and for example, don't exceed a certain amount of occurrences in all the corpus. And you may want just to build a more like this query out of n query terms. So maybe you don't want to exceed 20 query terms. And you may want to apply a boost, which basically make more important some of the terms. So how effectively a term can be boosted? If you specify through the parameters that you want to enable boost, the score of each term will effectively boost the term. So a term that is considered more important will be additionally boosted in the one of this query, making more likely documents to be similar if they contain that term. On the other end, at configuration time, you can also boost specific fields. So in your domain, you know